So we're going to look at this problem that says we have radioactive uranium-235 has a half-life of about 7 million years. It says, suppose you find a rock and chemical analysis tells you that only 1/16 of the rock of the rock's original uranium-235 remains, and it says how old is the rock. So in this situation, this is a half-life problem. So the first thing I'm going to do is I'm going to write out the half-life formula. And it looks like this. And in this formula, and you'll find this formula on your formula sheet or in your book, the different parts of this is the future amount, like what will remain. This is the initial amount, so what you start with. And then we have lowercase t, and that is the time that has passed. And then we have capital T, and some of them in the book it says capital T half or capital T double if you're talking about the doubling formula. So the capital T, this stands for the half-life. The half-life is the time it takes for the item or object to decay to half its original value. So in this problem, we are told that this radioactive substance has a half-life of about 7 million years. So this is my capital T. And it says, suppose you find the rock and it tells you that only 1/16 of the rock's original uranium-235. So it doesn't even tell you how much you start with, but it's telling you that in the future, 1/16 of the original is left. So let's think about what that means. So it's 1/16 of the original amount. So what I could do, it's 1/16 of Q sub 0, which is the initial amount. And when you say Q, when you say 1/16 of, it means to multiply by. So this is capital Q. That's the future amount that will be left, this much. So I'm going to put that in place on this side. And so now I have this situation. And then I can plug in the half-life, it's 700 million. And I'm going to put 700 here, but I know that this stands for 700 million. So I'm just going to write that there to remind me that there's units of million years on this number. Now, and by the way, I forgot to mention when I was explaining the formula, the time and the half-life need to be in the same unit. So if it was months, then you would have to have both of them in months. If it was years, then they would both have to be in years. This one is million years, so they're both going to be a million years. So now that I'm at this point, I'm going to say, all right, well, I've got two unknowns here. I can't solve something with two unknowns. So what I'm going to do is I see that they both have Q sub 0. So I'm going to try to divide this out here, and look what happens. It divides out of both sides, and I'm left with this. 1/16 is equal to 1/2 to the T over 700. Now, how you would solve this problem in algebra is that you would use what are called logarithms. But we're not going to talk about logarithms in this course. So instead, we can do a estimation. And we can do an estimation by doing like a guess and check. So let's see. This is, and I can talk through this. I can also use the calculator. So first, let me just talk through it and see how this would work. So basically, you have an equal sign. And for the two sides to be equal, the values have to be equal. So when I have 1/2, what power would I have to raise it to for these two to be equal? Well, that power that I'd have to raise it to is 4, because that 4 will apply to the denominator, and then I would have 1/16 is equal to 1/16. 1 to the 4th is 1, and 2 to the 4th is 16. So this exponent here, this portion here, t over 700, would have to equal 4. So what number could I put in place of t here? Well, I can solve this by multiplying both sides by 700, or just thinking what divided by 700 would be 4. And I would say it is 2800. So that's what would go in place of t. So multiplying both sides by, I'm sorry, I wrote the 2800 on the wrong side. Multiplying both sides by 700, I would get t equals 2800. So this is what you would have to have in the numerator to make this, what I circled, equal to 4. So that is one way to think about it. And so when I look at my math lab and the choices in my math lab, there are choices that are, it's like multiple choice. So we have, I'm just going to write a few up here. There's 2.8 billion. There is 1.4 billion. There is 3.5 billion. And so when you say 2800, remember I said they have to have the same units. So 2800, if I put 2800 million years, that is, the word millions means there's 6 zeros. So 28, 1, 2, 3, 4, 5, 6. So 2800 million. But this is also, if you were to read this number, this would be thousands, millions, billions. So it's 2.8 billion. So I choose that one. Now, how could I look at this with the calculator? To look at this with the calculator, what you could do is you would put in some numbers and do like a guess and check method. Because like I said, we're not going to use the logarithms to solve this. So let's grab the calculator. So I have it here. And let me show you what I'm putting in. I'm going to put in 1/2 and then caret symbol. And then I'll put a value in for t. So, I mean, I know in order for it to decay, I need to, you know, half of it would be 700 million. So I could put that in for t and I get 1/2. And then I would keep putting values in for t so I can change this. So you saw I made a shortcut there. I did second enter. And that brought down the previous line so that I can go change this. I'm going to do second delete, and I'm going to put in 14, and I'm going to try that, and I get 0.25. So I need to try numbers until it gets down to 1/16. 1/16 is 0.0625. So I will keep trying. Let me hit second enter twice now, and I'm going to try, and I don't have to do multiples of 700. I mean, we know it ends up being 2800, but you could just try numbers. Maybe I'll go to 2500, and I'm trying to get a number that's close to this, and now I'm getting close to it, so you can see that. And then once I go, let me try 3000. Well, when I try 3000, I see I'm above it. So it's really kind of looking at the choices that you have in the My Math Lab and kind of seeing which one works. So the 1.4 billion would not, and we would have to try those different ones and see. There's also millions in there, and we're above those. So it's just a matter of doing like a guess and check for that, or kind of walking it through. Like I said, this would have to equal 4, this exponent, in order to make it equal this left side. So that's how you approach this type of problem.